So this is the first panel of the afternoon. We'll have a second panel moderated by Adam on the business side of the equation after the break. For this panel, we're going to talk about embedded systems and the opportunities and growth of embedded systems. If we can please, I'm going to do a brief introduction, and then each of the panelists, we'll do it in a conventional way, this panel. I'll do a brief introduction, setting up the, hopefully, the situation as well as I can, and then each panelist will do a short statement in terms of what they see as the challenges and opportunities, and then we'll open it up to questions among the panelists, myself, as well as the audience. So we'll do about 15 to 20 minutes of slideware, if you like, and then open it up, and hopefully this will spur some questions and activity in the room. So what distinguishes embedded systems are not a new concept. Essentially, for those of us old enough to remember 8 and later 16-bit microcontrollers, been around forever. These were often buried in commercial industrial applications, so nobody really paid much attention to them. But they did the job for us silently. Today, embedded systems are, if you like, a hot topic. They are ubiquitous, diverse, complex. They take layers of hardware and software to assemble. So embedded software especially is become a very large domain, and is hiring lots of software people and competing with lots of software people for embedded applications and real-time operating systems and so on. Embedded systems also will contain processors, generally have some form of real-time constraints associated with them, have software stacks on top of their kernels, so there's a lot of layers of software in some of the more complex systems. And obviously, they have to have interfaces to the outside world, whether they be general purpose, low speed, all the way to very, very fast optical interfaces. So that's kind of the today versus yesterday. Embedded systems typically have an entire ecosystem associated with them to build.
Somebody's got a live radio.
I've probably got something. Sorry. Another issue with embedded systems, interference.
No, it's just the crappy radio.
Apologies. Yeah, crappy. Well, yeah. Sorry, he just saw that my smartphone was not a BlackBerry, and he accused it of having crappy radios.
No. It's the lousy edge connectivity in here, because if it was on a 3G network, it wouldn't be making that racket, right?
It's on LTE. Yeah.
But I'm only getting 3E edge. Never mind. Okay. Continue.
With the embedded systems comes obviously an ecosystem to support the development of the embedded system, both on the hardware and software side. These embedded systems, as we mentioned, have a tremendous number of applications, from everything you carry around in your pocket to very new things like Raspberry Pi and so on, which just sold its millionth unit not long ago, based on an ARM Cortex processor. And so everybody from the old hobbyist, all the way to the sophisticated engineer is getting satisfaction from all these systems. And of course, you've got embedding in anything that you look at these days, your car, your smartphone, and so on. Now, the reason for the platforms, and this came up in one of the talks this morning, is in order to leverage the large investment in these kinds of systems, we have to have multiple applications, multiple modes, and so on, that allow a large enough diversity of applications to recoup the investment and build the gross margin that is needed to justify the investments. Something I just pulled up from a while ago, but still quite valid today. So this goes up to 2012, but just as estimates. As you can see, the chocolate brown at the bottom is essentially the software in the platforms. And as you heard, a typical large, sophisticated processor or sophisticated device type of effort today takes about $50 million plus or minus, so $20, $25, $30 million for the less expensive ones, maybe going up to $75 million and more for the more expensive. But a significant part of that investment is going into embedded software, and it's growing faster than any other part of it. We used to complain about hardware verification. Now we stop complaining about that and complain about the embedded software development costs for these types of applications. So things are changing radically, and that's why we have Gwyn and Mahshad on the panel, is because they help to provide the infrastructure that enables embedded systems of these kinds. I'm obviously not going to cover it, but so we get all the different views. This is a TI OMAP 5 platform used in multimedia and other applications from Texas Instruments. Was a very, very, and still is a very, very popular platform. You can see we can have a hardware view that talks about all the interfaces, and it has multiple Cortex A15s in this case, and other types of cores for different media processing and so on it. So it's a huge and complex SoC at the heart of it, and an entire infrastructure to program it and to build the embedded application or applications. So we get another view of it here as an applications processor. That's the same device, but in the applications view, and yet another view of it looking at Android running on the platform. So when you bring out a reference platform today as a company doing a embedded system, you have to service not only just the device, but obviously the ecosystem is an important part of the uptake of the entire device. If we look at the semiconductor industry, a large part on the hardware side of putting these systems together is an assembly of IP. No company today is capable of producing all that IP that they need for their next generation single-handedly. So we have a bunch of very large IP suppliers at this point in time, starting with ARM at the top, and running at I've forgotten their latest revenues is well into the hundreds of millions, though. I think it's something on the order of 300 to 400 million. And then Synopsys being next as a broad-based supplier, and then all the way down the map, and some continuing consolidation in the IP industry. And many of these companies are selling physical IP, design IP, verification IP, and so on. So the software and tools industry that enables embedded software platforms is not only the device, but it's the embedded real-time operating systems, the software ecosystem for the development of the device, maybe a tremendous amount of modeling investment, open source stacks for enabling the applications and so on. And then of course you have 100 soldiers behind that doing assembly, testing, integration, probing, and so on. So a huge effort to put these platforms together. So that's the basic introduction to the embedded systems, and we're going to go on now to, I don't want to show this slide, I don't think we need it. We'll go on to Gwyn's presentation, please. So Gwyn is with us. Gwyn, I'll let you give a brief bio, and then...
Up there, or?
And then...
Is it here, or why don't I come up there?
Either way.
Then I can see my slides.
There you go. I'll sit this way.
You can sit here. Yes. Thanks. Hi, my name is Gwyn Fisher. I'm the Chief Technology Officer at Klocwork. We're a company here in town. We run to about 100 people right now. We've grown from 2 people to that point over the last 12 years. So not exactly Cognos, but we're getting there. So why aren't we all scared yet? So I was asked by Ken to pitch in on the software opportunity of new devices and the hybrid hardware-software kind of zeitgeist. And the thing that occurred to me that people just don't think about at all is what we spend all of our time thinking about, which is how do you actually secure what you're creating? And how do you ship something knowing whether it's secure or not, and how on earth do you ship it if you don't know that? Because all you're asking to do is to land up on the front page of some large liberal publication in the US. Excuse me. So the machine-to-machine sort of concept, which is really gaining all the sort of sex appeal in the media these days, really is a fascinating area for, well, both exploit and opportunity. Anytime there's something that you can do wrong, you will, by definition. And when you're doing it wrong, there's an opportunity for someone to help you do it right, basically. And so in the space of machine-to-machine, or the Internet of Things, which people like to call this, Turing problems have raised their head again, right? We thought we had solved this with capture. Yuck. But the Turing problem is back again. How do you know that what you're talking to is the thing you think you're talking to? And how do you know it's capable of doing the things that you expect it to be able to do? And how do you know it's going to tell you what to do? And all this kind of crap. So I was reading a fascinating article out of Japan this morning about self-parking cars. So there's now this whole thing of it's not enough to drive an electric car. If you're leaving the electric car running too long, then you're wasting your battery. And so somewhere, probably in the north of Canada, is going to be sucking up that battery in a landfill at some point, so that's a bad thing. So what we want to do is optimize how that car gets in the parking lot to your average fat American in front of a mall somewhere. And so, you know, you've got a whole set of problems there as to how you actually make that car move at the right time to the right destination, et cetera, et cetera. And so none of this is off the shelf. You can't sort of go somewhere and say, you know what, I want a parking management system, thank you very much. And you know, our friends in the open source community will go, well, we've got 15 of those, and they've all been validated by 1,000 eyes. You know, you have to build this yourself, and there's no support infrastructure for the stuff that you guys do, right? If you look at the web space, which is sort of the I guess the poster boy for doing it completely wrong, but kind of recovering over time. You know, there's a $1 billion tools industry there that is entirely organized around helping you do things right. We still do it all wrong. The most recent survey showed that 28% of vulnerabilities in the wild are still SQL injection. I mean, come on, we learned how to write prepared SQL statements in high school, for God's sake. But we're still doing it wrong 20 years after we started. So, you know, but there's a $1 billion tools industry, and I'm taking my little piece of it, so I'm quite happy that people are still stupid. So it's all good. But, you know, our sort of goal in life is to try and help people do things better. But why don't companies assume that they're doing it wrong, right? I guess this is sort of the fundamental crux of everything, right? If you assume you're going to do it wrong, at least you've got the opportunity to start doing it right, because you're going to take your senior designers, your architects, and you're going to try and push them down the road of, you know, figure out how to do this right, and then we'll tell the interns how to do it later. But, you know, it's kind of expensive to do that, and people don't like to do it. So again, every time there's an opportunity to do it wrong, there's an opportunity to make money helping people do it right. And as Ken was talking about, nobody makes their own hardware anymore. You buy IP from other people, or nobody makes their own device anymore. You buy hardware from one place, you write your own software, or you create your own hardware, but you get your software from somewhere else. And so this whole notion of holistic security doesn't really exist, right? You don't have any idea of what you're actually shipping anymore, because you're getting bits and bobs from Asia, and you've got some carefully crafted backdoor from our friends in China. You know, whatever is going on, you know, you're shipping stuff that you don't understand anymore, and you are coming to the table with a set of assumptions which are by definition invalid, right? So you've spent your whole life designing microelectronics, so it's just a software problem, right? And if only the software engineers would get their asses in gear, then nobody would be able to hack your device. And of course, you come to it with a software bent, then, well, you know, those hardware idiots don't know what they're doing. So, you know, it's just, again, it's a sinkhole in the process, and anytime there's a sinkhole, you can make money filling it in. So this is something that we deal with all the time. Security is a checkbox. This, very unfortunately, goes all the way up to people who are building things like bombs and tanks and ships and all kinds of stuff. So the DoD, bless them, have said if you want to sell anything to the DoD in the US, you have to follow the SANS Top 25 coding standard, which says really useful things like you can't have SQL injection, which is great if you're writing web application, but you know, you're writing a guidance system for a smart missile. You know, I don't think the guys standing on hilltops with RF modulators are worrying about SQL injection. They're worrying about how they can spam your smart bomb with enough crap that it's going to fall on the wrong town. So following a standard isn't really good enough. You've actually got to construct a secure development lifecycle from the ground up, whether you're doing hardware, whether you're doing software. And some typical sort of responses to this, my developers don't want to be bothered. Whether we're talking hardware engineers, software engineers, again, that's a perfect opportunity to go meet the editor of some liberal publication down south. The second most obvious thing is I'm auditing, right? So I've spent a fortune on getting people who know security. They're fundamental security guys, and they're going to tell us everything we've done wrong. And again, exactly the wrong thing you can do to any given organization. So what can we do? And where's the opportunity, I guess, for people to make money in this space? How am I making money in this space? So lots of things. Education is sort of the cornerstone of everything that needs to be done in security. Again, if you come to this sort of notion with the idea that you're going to do it wrong, then figuring out how to do it right is all about education. Whether you're educating yourself, whether you're educating the top of your organization, the bottom of your organization, doesn't matter. Educate, 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 never ever stop. Security can't be done once, you've got to do it all the time. Figure out what it is you're trying to protect. If you're making a device that is going to be implanted in someone's heart, it's pretty obvious what you're trying to protect. You're trying to protect that person from dying. If you're creating, let's say, a chip that goes on a smart card, again, it's pretty obvious what you're trying to protect. You're trying to protect the assets that smart card are there to quantify. But in many other cases, it's not necessarily obvious what it is you're trying to protect. And that's the hard part of this, right? So modeling, understanding what it is that you're doing, what it is that you're protecting, and what's going to go wrong if, again, under the right assumption that it is going to get stolen, what are you going to do to recover from that so that you're not on the front page of some liberal publication with your trousers down? That's the place to start and understand what it is you're trying to do. So anytime you've got an edge, harden it, understand it, whether it's a hardware edge or software edge. Those diagrams that Ken just put up of all the wonderful things you can do with the TIO map, every single one of them is broken. Just come to the table with that understanding, with that assumption, and life will be cool. All right. There we go. Thanks very much.
Thank you, Gwyn, for that liberal. So you consider the New York Times a highly liberal publication at this point?
Well, I live in the States, so
okay.
Yeah.
Mahshad is CEO of Protecode. He'll also a local company, and he'll give us another perspective.
Okay. How do you change the chart here?
Oh, you've got to click
the
the
device
over there. It's old-fashioned.
Mouse.
Computer.
All right. So I'm running a company, software company in Ottawa. I've been in the industry in Ottawa area for 35 years, and I probably started my job as hardware designer, algorithm designer. Digital signal processing, DSP was a new thing at the time, and I moved on from hardware design, switching design, chip design involvement, a lot of activities in what used to be Bell Northern Research, and RF design, photonics, and around 10 years ago I saw the light, and I changed sides. I moved on to software because software is eating the world. This is what Mark Anderson said of Netscape, one of the biggest investors in the LinkedIn and a whole bunch of other activities. And it is true. When you look at amount of software in the world, and embedded software specifically, our life will probably cease to exist the way we know it, without code, without software. And this is obvious. More instances of embedded software than any other kind of software, whether it's in your egg timer, to your camera, to your phones. I mean, how many phones is it that Apple is shipping and the RIM used to ship, etc.? 30, 40, 50 million a month. Software is everywhere, and it's really in every aspect of our life. It's everywhere, but this code is not created from scratch. People hardly write code from scratch. I mean, I'll use the example of a PowerPoint presentation that I created. Who creates PowerPoint presentations from scratch these days? You basically go out and take what you have before, you go onto the web, you find some nice diagrams, pictures, maybe quotations, you bring it in, maybe paraphrase it, you take your colleagues' presentations, previous presentations, you add your own creativity and you come up with a new presentation. But if somebody asks you what's yours and what's not, and where did each bit and piece come from, you have no idea, nobody keeps track. The same thing is happening generally in complex systems designs, and especially in software. So people do code reuse. They reuse code that's been already developed in the company, in the organizations, in the university by their research colleagues. We bring in code for trial basis, we buy code on a commercial basis, and of course in the last 10 years, probably the biggest driver of the complexity of the solutions, software solutions in the world has been this public domain software, open source software. There were a lot of religious wars over the open source and the availability of the code for free, and to a large extent those arguments have passed. And we've come to a stable environment where public domain content is being created, is being peer reviewed, the source code is accessible so you know what's in it. In fact, one of the earliest mass adoptions of open source public domain software was in security solutions, in firewalls and networking solutions, because you could see what's inside it. You would be sure there is no backdoor entry to the code. When you look at the public domain software, you can basically find anything. My best developers, they don't write code from scratch. In fact, the more resourceful they are, the better they are in bringing code, identifying code, bringing it in, modifying it, and adding their own value added, their own creativity to get what needs to be done, and there is nothing wrong with that. We always said code reuse, design reuse. This is the ultimate case of a code reuse. We have a database. I will explain what Protecode does. We basically scan code. We try to detect similarity between the code in a company's portfolio or in a research organization's portfolio, similarity between that code and a public domain software, known software. And if we find any similarity, we bring up the attributes. This is the owner of the code. This is the license associated with it. These are the security vulnerabilities. These are the encryption properties, if any, export control restrictions around it. In order to do that, we compare the code to a database of known software. Therefore, we know how much open source software is out there. Our current database is about 300 billion lines of code, and by no means we've exhausted it. We've gone through the usual forges, what we call the structured forges, but our university codes, our codes are coming up in the blogs, in the books, etc. And it's difficult. It's really difficult to catch up with them. So anything you want to happen, you want to do, there is public domain code for that. It's wonderful, code reuse, but there are some challenges. Back in the hardware days, we had the concept of the bill of materials, approved components, approved suppliers, components that were approved for the certain fire hazards, for explosivity, for whatever. We had a bill of materials that we could ship with the product to the customer, to the market, to the manufacturing. These concepts are just becoming popular in the software domain, especially in the embedded software. When you look at the code that exists in a camera or in a mobile device, any code that has more than 3 developers involved in putting it together, it's very difficult to know what's inside it. As I mentioned with the PowerPoint example, nobody keeps track. Nobody creates code from scratch anymore. And some of the functions are very complex. You just pick it up. You pick up the whole UI subsystem. You pick up the whole GUI subsystem. The little pie charts that you want to create on your little phone, they come from somebody else. There is a chip drivers, there are the application examples that are shipped with the chip that the people take and modify it. There are RTOSs, real-time operating systems, protocol stacks, etc. When you look at what goes into a standard mobile phone today, there are literally thousands of contributors. And we did a breakdown of the Android project, open source project. It's not a monolithic project. It's 120 different sub-projects in it. And every one of those we basically stopped. Basically, you can go down in these sub-projects and try to find the genesis of every piece of code. The issues that it creates, of course, is ability to track the pedigree of the code for managing various aspects. Quality is something that we care about. How can you manage the quality of your product, which has software in it? How can you manage the quality if you don't know what's gone inside it, if you don't know the components? There are other aspects that the companies do care about. If you are doing tech transfer, commercialization, people do care about the pedigree of the code, anything from the IP aspects to export control to version of the software, the quality of the software, origin of the software. And one of the issues that people are beginning to understand these days in complex embedded environments is ability to create a granularity, understand the pedigree of the code, and manage the code the way that we used to do in the hardware 20 years ago. Let's leave it at that.
Okay, thank you, Mahshad. We're running a bit late, but we're going to give Alec a little bit of platform time here. So Alec Saunders, VP of... he's got ecosystems and embedded, so that's what we want to hear about. And then we'll take some questions.
So thanks. Bit about myself. I've been at BlackBerry for just over 2 years now. I've worked for large companies and small companies. During the 1990s, I had the notoriety or the honor, depending on which way you look at it, of being the guy who was responsible for introducing Internet Explorer at Microsoft. So don't hold that against me. I spent a chunk of the early part of 2001, 2002 as the VP of marketing at QNX, where I got to know their embedded operating system very well. Went from there to a telecom startup, then ran a startup of my own for 8 years. And lovely to hear Antoine say we have to have headquarters in Canada if we want companies to survive. I went to my board of directors at the time and said, I think I've run out of gas on this startup. I'd like to help you find a new CEO. And then I banged on BlackBerry's door until they gave me a job because I wanted to help them with their ecosystem problem. So, to set all of your minds at ease, there's $2.5 billion in the bank. Your BlackBerries are not going to stop working tomorrow. Okay? Now that we've cleared that up. I have a whole slew, 15 slides to get through, but I'll mercifully keep it real short. The way that we communicate, and I constructed this from the perspective of how I think about ecosystems, because I live and breathe this stuff on a day-to-day basis. And the opportunities, when you start to talk about it embedded, are really across a whole series of different places. They're not necessarily just in hardware or in software, they're in all kinds of different places. And the reason why that's happening is because fundamentally, communications is changing. You know, we used to talk about being connected. Remember the old phones and you'd be able to phone somebody? That was a pretty big deal, being able to phone somebody from your car with a brick this big that was made by Motorola, right? We started to add content and commerce to those things. We started to add community. Social networks are now the way that the people handle social networks, or most often access them, is via mobile device. And these days we're starting to look at the mobile internet too, and all the different kinds of wearables and other things that are popping up all over the place. And so to me, the mobile internet is really about the Internet of Things. It's about people and communities, definitely, lots of different groups of people who that you'll try to access there, but it's also about the content and the services that come to those devices that you're able to deliver there. So, I mean, you may not think of your television as necessarily being a piece of embedded electronics, but mine has the ability to, you know, let me access the internet, Netflix, et cetera, et cetera, et cetera. And somebody built some embedded software, probably based on QNX, that's inside that television. And then there's, of course, the world of intelligent things, and very hot space. As I was on my way in here, one of my employees who happens to be at CTIA texted me to say, wow, there's this, you know, this incredible session that's going on about wearables right now. It's easily the hottest thing at CTIA. Now, these days CTIA is kind of a dying conference, so maybe, anyway. But the point being that these things are incredibly important. And as we start to think about them ourselves from the perspective of the platform manufacturer, we're dumping in technologies like Bluetooth Low Energy, you know, NFC, all kinds of things that make it possible for the device itself now to become an extension of you personally and interact with what's going on in the world around you. Management's another big area. You know, we're famous for managing handsets, but you can also use the same technology that we've built to be able to manage and update software in an automobile or in, you know, in Coke machines. That's another place where that software gets deployed as well, is to be able to push out updates to individual devices that are in field already that have embedded applications in them. And I think I'm going to stop there. I've got another, like I said, eons full of slides, but I think we'd rather run the panel at this point, right? Okay?
Thank you.
Good. Thanks.
Okay, thank you, Alec. We're going to open it up to questions now, and I think we'll take a bit of the break time, maybe eat into it a touch, but we certainly want folks to get the break and the collaboration. So I'd like to open it up to questions in the room. Any burning questions? We didn't spur too much controversy, apparently. Everybody agrees with the panelists, is that? So let's go back to the one question, which was the panel topic to begin with. You know, where are the big opportunities in embedded systems in terms of Canadian companies being able to play in that value chain? And I'd like each of the panelists to, you know, give a short answer to that question.
Right. So, well, obviously, I tend to think of things from a software perspective, but the really cool thing, as far as I'm concerned, is there's no such thing as an embedded device anymore. There's just hardware, right? So stuff happens. So whether you're driving a car, you're flying a plane, you're dropping a bomb on somebody, it's an embedded device. And anywhere you've got an embedded device, you've got an opportunity to make money because they're all built wrong. So, so that's cool. That's a good place to start. Doesn't matter if you're Canadian, Indonesian, wherever you're coming from. There's a great market to be had in that the whole world is going embedded. It's going to be driving your car. It's going to be complaining about your neighbor. It's going to be posting pictures of your kids on the internet. These devices are doing things for you, and you know, we can't even see 3 years down the line, let alone 20 years down the line. Who'd have thought 3 years ago we would have had a VP of BlackBerry saying there's still money in the bank? I mean, things move so quickly, and that wasn't a criticism. Sorry, it was just, you know, things move so quickly you cannot possibly keep up, you cannot possibly predict what is going to happen. But if you don't go into it with an assumption that you're going to do it wrong, then you are going to do it wrong, and that's where people like me make money. But it would be cool if people like you made money instead by doing it right. That's what I think.
Thank you, Mahshad.
I mean, going back to Antoine's presentation earlier on regarding the movement of a lot of technology and industry out of the Western world as we know it, software is one of those areas where we do have an advantage and we have an opportunity to actually establish ourselves. Yes, the mortar, the physical devices are moving out, the fabrications moved out, but more and more those physical devices are useless without the intelligence that goes into them, drives them, and makes them do things. And we do still have an advantage. Part of it is because these devices at the end of the day interact, or a lot of them interact with people. And depending on the location, geographic location, and the culture and the background and the way we do things versus the way other people do things, there is some locality involved in creation and in interaction, and the software is now what delivers that locality. What I see on the screen is what I like to see, and when I see a device that's coming in from another culture, I can tell that right away because things are happening differently from the way I'm used to, whether it's the translation, which is really transliteration, whether these are the icons. In some cultures, you like to see someone in a uniform with a hat saying thank you, bowing over when you do a ATM transaction. In our culture, that's not common. You see a message, thank you. So there are differences. The software that delivers functionality that people use, whether it's a user interface in terms of the GUI, whether it's a functionality, the way the car accelerates, decelerates, etc., it is local. We have a lot of opportunity in Canada specifically to tap into that opportunity, into that capability, into the knowledge that we have, create the software that drives these devices, even though the fabrication of these devices are outside. And as we've seen, your charts showed it in terms of the investment in the software. I've had interactions with a lot of silicon companies, chip companies, and some of them are telling me about 75% of their workforce, R&D workforce now, is in software. Well, Canada can be a center for that capability, for that knowledge.
Thanks, Mahshad.
Alec?
So I'm going to be controversial. I mean, I travel the world talking to software developers. And last year when we were launching BlackBerry 10, my team, for a platform that didn't exist yet, so there was no economic opportunity whatsoever, we persuaded 60,000 software developers to build 70,000 applications for something they'd never seen before. It's not hard to build software anymore. And the wonderful thing about it, except if you're from the first world and are thinking that software is going to be the way that you're going to build a competitive advantage for yourself, is that it costs nothing to get going. You know, I routinely get pitches from governments that say to me, you know, we want you to come and build, you know, and spend millions of dollars or hundreds of millions of dollars to build something that will help us to you know, to further our economy. And my response is all the same. You know, I just, when I was in Brazil, I was at a convention of Adobe guys on a beach in Recife, or Maceió actually, which is in the northern part of Brazil. And a kid with a laptop on a beach in northern Brazil can produce an application more cheaply and more quickly than anybody can in Silicon Valley, and they can get it to market through the internet without you know, having to invest in distribution channels or any of the things that used to be hard with physical goods. And the same is true in India, in China. 43% of the applications from my catalog at launch came from China and India because we offered them each $100 per application. And $100 in that economy is real money.
Can I ask a question? How many apps, Android or Apple, are you using here that are actually created in China or Japan compared to West, compared to North America or Europe?
You don't know.
Well,
You
none
don't.
for me, because I just can't find the right app that satisfies my
Okay.
needs.
So my
Coming
two
from
most
the-
successful developers in the world, one's located in Hong Kong and one's located in Shanghai.
Yeah, there is a difference between doing the work in the local place because it's cheaper and actually creating the app, the requirement, the specification, and the integration and shipping it as an end product. We do a lot of business in India because there is significant software development happening in India. All of them subscribe to our solutions because they are an R&D shop or a contractor of a North American or a European company. They do not create the product for the consumption worldwide on their own. They don't market it on their own. But so far, it's been a job shop.
Yeah, but Mahshad, I can tell you that is changing.
Okay.
You go to India and you find Indian software that's been created by Indians for Indians. I saw a wonderful example about a year ago where a group of doctors had built an application that let them remotely examine X-ray images using a BlackBerry. You know, and there's lots and lots and lots of that kind of stuff happening where people are starting to. They were formerly job shops, but now they've got the bug. Now that they know they can influence their own economy, and they are building applications in market for consumption in market.
In market.
Yeah.
So
Maybe we should take a Gwyn.
No, be quiet.
1 minute. 1 minute rebuttal, and then we'll
Fine.
take Alex's question.
No, sorry, I lost the track of where you were being controversial there. Are you saying that software is cheap and hardware is difficult, or
I'm saying that we tend to look at software as something that we can uniquely do well in the West. We think of ourselves as innovators. That's just arrogant. There are other people in other parts of the world who are doing just as good a job and will quickly outstrip us if we don't
focus in hard on what it takes to be innovative. You know, some of the best software developers I think in the world are Israelis, because every time I see a product that comes from Israel, what it is something where there's some big science that it's hard for somebody else to duplicate.
Okay, yes, I wouldn't disagree with that. I would say, however, if you are going to install anything from certain parts of the world on your BlackBerry, you know, on your own head be it. They're all broken. All of them. Off you go.
Well, I would have had a comment that sometimes that sophisticated software doesn't have to be sophisticated. What's the chicken app?
Oh yeah, Angry Birds. Yeah.
You know, so you can make a lot of money without it being sophisticated as well.
Absolutely.
Alex? Yeah. Could we get Mike? Okay, and then Alex, and you had a question as well. Okay.
So 2 questions, and your comment about making money maybe was a good one. I think I read just recently that 85% of all apps are free, and that within a couple of years, more than 95% of them will be free. So, I mean, my first question is I guess, what is the app model going to be financially in the future? And probably, I guess my second unrelated question, from an embedded system perspective, there's lots of researchers in the room. As industry leaders, what do you see as the gaps or the research topics on embedded systems where you would steer academics?
Who wants to take that?
I can take the one on the business model pretty easily. It is absolutely changing. What's happening is you're getting a much more of a try before you buy kind of model that's being driven primarily by Android. People on Android just won't pay for anything. So if it's bad, if it's bad on an iOS or a BlackBerry phone, you can count on it being twice as bad on an Android phone. What you're seeing it replaced by is in-app purchases. You're seeing it replaced by advertising models. Advertising models have a very spotty record because unless you can fill the ad inventory with locally appropriate ads, they just, you know, they're not very effective. But there are other monetization models that are coming to market. And the other thing that's happening is that brands are starting to build applications that are associated with the brand where they don't necessarily care about the monetization model anymore. What they care about is having their brand in front of the customer. That's the reason why the NHL's app is always free, right? So
perhaps we should widen the conversation to value-add software, not just smartphone apps.
Well, I was going to say, so we are, anytime you talk about software, you do tend to sort of polarize around apps, right? Because it's $4.99 and the absolute maximum is probably 99 cents, and you know, you can fling birds at something and it's cool.
I think it's angry. That's the one.
But you know, and that is incredibly compelling as a market. You know, it's selling sneakers to China. You're dealing with a consumer. There's billions of them, and if you can only get 99 cents off each one, you're still going to retire richer than everybody else. That's really cool. A friend of mine wrote one of the first note-taking applications on the iPad. He bought himself a Porsche off the back of it. Good for him. I'm not jealous in any way. You know. It is really cool, but that isn't the embedded market, right? That is the consumer-facing smart device market, and we should be careful, I suppose, in terms of defining consumer in that context. L3, for example, is putting hardened Android tablets on their tanks. There's a scary concept. You've got a PlayStation now to fire your weapon. Pretty cool, but pretty scary. But the market as a whole is a heck of a lot bigger than that, right? So whether you're making devices to help drive a car, whether you're making devices to help people cross roads, whether you're making devices, you know, devices exist everywhere in the world. The point that Mahshad was making earlier, not only software everywhere, devices are everywhere. There's no such thing as, there's almost no such thing as a pure play non-device anymore. You almost can't do one. Right, so there's the PC. You could make a point that that's a device these days because people don't really understand how they work anymore. I just bought a new Mercedes, thank you very much. I don't feel like I'm driving the thing anymore. I'm kind of giving the ECU gentle nudges every so often, some advice as to how I'd like it to drive down the road. And it sort of ignores me most of the time because it's German and it's just arrogant. But, you know, whatever. It's there's no one German in the room, is there? you know, that space of the market is just sort of expanding ever more horizontally, and it is taking over our lives. And we should be grateful as software and hardware providers that there is this opportunity within our lifetimes to sort of to do something that is literally going to touch everyone, from our grandma who was paranoid about losing a password to Lithuanian hackers to, you know, some kid who hasn't been born yet who just can't wait to get the next BlackBerry or iPhone, whatever.
No, I would like to echo that. I mean, applications are the sort of very visual, visible part of the, both visual and visible part of the software that everybody can relate to. But there is so much software. I mean, when we talk about the embedded software, a lot of times we don't see that embedded software. There is software in everything. This microphone's got probably so much software running inside it. My little desktop phone has more software in it than I had on my Mac 10 years ago. A lot of it we don't see, and in terms of the value, you look at the $499 for the app, you should also look at the $35,000 for certain software applications, and people pay for that. There's significant money for it, in it.
Yeah. It's actually a very interesting point, because that whole marriage of hardware and software together is, I think, the way that you're going to make money. As an example, at one point in my career, I was responsible for Microsoft's home networking initiatives way, way back. And one of my fantasies...
Well, you're just one success after another, aren't you?
Yeah, well, anyway. It works very well. The point I was going to make, before I was so rudely interrupted, I recently bought a Sonos system. And after 12 years of screwing around with trying to get PCs, which are general purpose devices, to be able to play music throughout my house adequately, I broke down and I bought an appliance. And the thing is, hands down, the best music experience I've ever had in terms of whole house audio. And you know, $400 for an inexpensive amplifier with some networking software built into it. So they've done very well with that. Same thing with the Nest thermostat. Who would ever have thought of spending $250 for a thermostat? But people can't keep that thing off the shelf, or on the shelf. You know, and it's a thermostat that's got some basic learning software in it that, and some nice design that understands what it is that you might want to do during the day with your heat. So I think that kind of marriage of the two of them together is really important. I think that building applications for a general purpose computing device, not so much. That one's a tough call.
It's a different market.
Okay. With that, well, we had one very patient gentleman, so last question and then we'll close.
I was wondering, rapid open sourcing of software, how do you deal with IP moving forward? And do you see IP playing a role in the software domain moving forward, or is it not even playing a part now?
Can you repeat the question for the audience as well? Yeah.
I think what the gentleman said is how does IP factor in the pure play software realm going forward?
Or open source.
Yeah.
It factors heavily. Open source doesn't mean that you give your IP away. Open source software is like, and this is a bad analogy, but I'm going to make it anyway. It's like a piece of art. When you create it, you're the owner. You may give permission to others to use it. It doesn't mean that you're relinquishing the ownership. It's like a copyright. It's like a book that you write. And when you provide a license, you're basically saving yourself the hassle of answering phone calls because people want to use your software. You posted your software on the wall, people see it, they like it, they want to use it. They can't use it, it's yours. In a lot of jurisdictions in the world, most jurisdictions in the world, when you create it, by default, you're the copyright owner. Nobody can use it. The only way people can use it is by asking your explicit permission, and that's called getting your permission. Rather than you answering phone calls or writing letters providing permission, you provide a blanket permission in what's called a license. So you license it. It doesn't mean that you relinquish your IP. A lot of software has patent associated with it. The license, the permission that you provide, deals with how you want to treat that intellectual property, whether for money, for free, or for some other return. A lot of the software on the open source, the public part of it is public because it's commodity now, but you add to it your own value added, your own innovation, and again, that's your own content. You don't need to expose it. You don't need to let the world know about it unless you choose to. So open source and intellectual property, they may seem at crossroads, but they are not. They are really orthogonal, have nothing to do with each other. You can save one and save your IP and still be open source.
Yeah. Can I just add to that, Mahshad? Because I think the impact of open source is really difficult to understate, right? You know, one of the biggest criticisms that people leveled at the old BlackBerry OS operating system was that there were no readily available open source building blocks to work with. And, you know, in BlackBerry 10, which is POSIX, you know, you program with C++, it's got a great HTML5 a layer on it, et cetera, we've got buckets and buckets and buckets of open source that we put out on a regular basis into a GitHub repository that we manage. And we encourage people to use those building blocks. And we see dramatically accelerated ports of software. You know, there was one before we launched where a Greek developer had taken a game he'd written and moved it from iOS onto BlackBerry 10 in 3 days, because we happened to have the right sets of open source building blocks for him to work with. So pretty cool.
Okay,
oh, Qnix has tons, yeah.
On that note, I want to thank the panel. We close it down.
10 seconds. Could I, on the subject of IP, I can't let it go without spanking my particular hobby horse, patents, the most evil thing on the planet. We're all watching the experiment in New Zealand, of course, incredibly carefully, and hoping the EU is going to very quickly follow thereafter. Call your congressman, that's not going to work up here. Whatever they're called up here, call them. Patents have to go. They're spawn of evil.
Okay, and on that, I got one more. Right here at home, not quite at home, in the United States, go and join the App Developers Alliance because they have a massive lobbying effort underway in Congress to overturn the software patent laws.
Thank you very much, everyone.